So this is the Omar level pump. This pump is located on the side of the machine, so it's easier to maintain, it's easier to access, and it's face mounted on the motor so that a foot mounted pump doesn't pull away from the face of the motor. This pump is mounted on the face of the motor. The motor and the pump move as an assembly when the fryer tank expands. We also have a float wash system here that allows clean oil coming back from the filter that comes up and washes the level floats in the bottom of the fryer tank. So this clean oil washes the level floats inside the level box. These floats are adjustable. This one's a level control, so we can adjust it based on what the oil level requirement is for the product. And this is the non-adjustable float that allows us to turn the pump off when it reaches height or on when it's too low. This float turns the pump on when the oil level is too low. This float is adjustable and turns off the pump when the oil level reaches the set point. Inside this level box is a pair of floats wired in series. Those two floats are a minimum oil level. They have to be made in order to turn the heat on in the fryer. That makes sure that the heat source in the fryer is covered with oil and not exposed to oxygen to eliminate the possibility of fire as a result of low oil inside the fryer. The Omar fryer is pre-piped and pre-wired for fire suppression. So we have two temperature detectors in the hood of the fryer. Those detectors will pick up and close the circuit in the case of 100 degrees Fahrenheit above normal operating temperature. There are two in the hood, and there are two detectors also in the steam vent. So there is a detector here below the mist eliminator filter. There's a detector here above the mist eliminator filter. So any one of these four can release the fire suppression system. The system is pre-piped for CO2. All we have to do is add an off-machine supply system, connect it to the pipework that's already on the fryer. So there are release nozzles inside the fryer tank. There are two in the fryer tank, and there are two more nozzles in the steam vent. Those are all pre-piped, standard feature of the Omar fryer. There is a pressure trip at the top with a damper door. So when the fire suppression is released, that damper closes, and simultaneously it shuts off all the controls in the fryer. So the exhaust system is shut down, the heat source is shut down, the conveyors are shut down. In addition to that, the fire suppression supply, which typically is CO2, in this case it's high pressure CO2, is released. That CO2 smothers the fryer, snuffs out the fire by removing the oxygen from the volume inside the fryer, and then it cools the cooking oil to the point where it doesn't reignite. This fryer is equipped with an oil injection system at the infeed end. This design helps kick the product into the product conveyor, so light products are encouraged to go into the cooking oil as they come into the oil and start to float. This oil, high velocity oil, will push that product into the fryer. So this is an option. It's fed by a separate pump that's located below the fryer frame. The pipework comes up inside the fryer, comes across here. So this is fresh oil coming back from the filter, and it's introduced right here at the infeed end, just above the product conveyor. The Omar fryer has a unique design in that there are no penetrations in the fryer tank for the sediment conveyor. So instead of having holes through the side of the fryer tank and a specialized bearing, this fryer uses the same bearing to drive the sediment conveyor and the sediment auger as we use in the product conveyor. This makes a longer life It also eliminates oil leaks as a result of the penetration in the fryer tank. And the drive for the sediment conveyor is up above the cooking oil. So there's a motor underneath the fryer apron, down the fryer frame, that drives this shaft drives that shaft. So the entire sediment system is driven from above. The product conveyor is also a unique design. This is an infinite adjustment in feed. So we can adjust from a drop transfer to a direct transfer or anything in between using these screws. We crank it down, we bring the shaft down, crank it up, we take the shaft up. This particular conveyor is equipped with compact grid belt from wire belt, but flat flex belt operates in the same manner. The submerger similarly adjusts infinitely up and down. This allows us to put that submerger shaft where we need it to be in order to pinch product if necessary, or to help push that product down under the oil as needed. There are separate drives for the submerging conveyor here and the product conveyor there. So they're the same drive. They're interchangeable motors, interchangeable parts. Separate motors driven in series, started by one button on the PLC, but the two drives run independently at the same speed with interchangeable parts. This fryer has CO2 nozzles as standard equipment. So this is one of the two nozzles that introduce CO2 in the side of the fryer tank. All pre-piped, Schedule 80 piping according to code, and it's a standard feature on the Omar fryer. Lifting of the conveyors, the heat exchanger, and the hood are all accomplished by mechanical screw jacks. These mechanical screw jacks are built by Omar, all assembled specifically for this application. We use tapped holes in the screw jack housing so that we don't have to try to get a nut on top of this bolt under a coupling. The shaft in this screw jack is plated to reduce corrosion, and it's filled with marine grade grease to help keep water out of it. There's a seal in the top of the worm shaft to help keep water out of the jack. And the surface of the casting is coated with an epoxy paint to make it last longer. This jack lifts every component on this machine. It lifts the heat exchanger, it lifts the product conveyor, it lifts the submerger, and it lifts the hood. Everything is tied together with mechanical links. No chains to bind, no trays to break off. It's all lifted through these mechanical links. And the mechanical links are stronger than any chain that can be put into this process. You can see the mechanical link here for the heat exchanger. You can see the mechanical link here for the product conveyor, and the mechanical link for the submerger. The whole system is lifted by 2-ton Omar mechanical screw jacks. These screw jacks are available to fit Stein fryers as well. They're a direct replacement and they're in stock. The heat exchanger is an electropolished ASME stamped weldment. This heat exchanger has a larger gap between the plates than competitive concepts. That results in better sediment transfer through the heat exchanger to make sure the sediment gets down into the sediment conveyor. Larger surface area, greater spacing equates to a better heat transfer than competitive designs.